All right, John, I'll be out of your way.
I'm going to leave India to you then.
Okay.
I'll just mention, keep people around.
Here you go.
I don't need anything. I just got out of class, so I'm going to just go with what's
I guess we're ready whenever.
I guess, sorry. Forgot. Go ahead. Okay, welcome to our weather discussion for this Friday. We will be here next Friday, but that'll be the last one until September, whatever the date is, the first Friday of the term in September. So,
Unless it snows.
unless it snows, then at least Michael and I will be down here talking about it. Probably arguing. It won't be comfortable. But I'll win. I will win, that's for sure. We're going to talk about the weather around the country. Michael's got some stuff prepared for the devastating heat wave that's going on right now in central India. So we're going to take a look at that too. He had the brains to put it all together. So he'll talk about that after I'm done with the current weather across the continental U.S. Let's start, Pete, with the satellite movie, not the radar. So here's our satellite movie. I think I remember saying this last Friday, that there were aspects of what we saw on the satellite animation across the continental United States that looked more summer than winter. And this, again, reminds me of that. These are kind of two rather separate regions of convective blow-off in the cold clouds here, but you'll see, you can see it even here, some of the bubbling up in the state of Missouri, and there's some also on the border between Nebraska and North Dakota. So we'll talk a little bit about those features. I won't do it with any expertise, I'll just draw your attention to them. And then we'll also look at a storm out on the west coast, and then this storm here, which presents itself just south of the Canadian Maritimes. And the high clouds, anyway, in this storm have really started to fall apart and almost don't exist at all. But there's enough of them in the northern and northwestern sector of the storm to be dropping snow in Caribou this morning. So April 29th, snow in Caribou, Maine. I don't know if it's as unusual as what we've experienced here in Madison. We've now had 7 days with at least a trace of snow in the month of April. So that, it's not a record. I think the record that I saw in the last 70 years is 13 such days. So that's nearly half the month, and that was 1950, I believe. But 7 is well above the normal. The normal is 4.5, and the deviation is quite small. There's not much deviation. So we're getting into the +1 standard deviation range, maybe even higher than that. Despite the fact, you might find this interesting, I did, the average temperature through the 25th, I think, of April for this month is only 3.3 degrees below normal. So it makes me wonder if the range of extremes for April's is very small. I just don't know the answer to that. But that's a pretty small departure for what I think we would all agree has been a prolonged and incessantly chilly month of April. So anyway, a couple of interesting things there that come out of what we've all experienced here over the last 4 weeks. And when you look at a satellite movie like this, it does give one encouragement to think that maybe things are going to change. This honestly looks like summertime type weather. And yet, I'm not sure you should hold out very much hope for that. So,
you know, I wanted to mention one thing
Yeah.
about April. I think April was unusual in the sense that we didn't have as many real cold days as we usually do too. I
Yeah.
think we do have several days in April normally where we drop in below 20, even down to 10. And then we have a few days typically where it goes up to 70 or 80 or more. And we had one day to 80.
we had 81 on Saturday last week.
And that was
Yep.
and that was it.
Yep.
And I think that's what's unusual. It didn't feel like a lot of breaks.
Yeah, I agree with that,
Like we
Greg. I think that's a good point. It wasn't unusually cold at any point, but it was consistently below normal. And that, you know, sort of a leveling of the average temperature fluctuation or something, or the extreme temperature fluctuation, and it put us at 3.3 degrees below normal.
Yeah.
Yeah, that's a good point.
That kind of looks like that on there too, where the fluctuation, you know, if you just look at fluctuations in there, they're kind of damped. There's a couple periods where it goes up, but not.
Yeah, just these two here.
Yeah.
And then otherwise hanging around the cold side of an average. Yeah, that's right.
Yeah.
So 3.3 degrees is all we could muster out of this anecdotally chilly April.
Right.
So,
Also, it's interesting to note, just in terms of the seasonal cycle of temperature in Madison, that the 81 we saw back last weekend is only 4 degrees shy of our normal average high temperature in July, late July.
Yeah, that's right,
18th
that's right.
to 20th is kind of the
Yeah.
warmest part of the year. So
and it felt almost like a July day because the dew point was around 60, the time was 81. and we had 0.91 inches of precipitation just before it. So the whole thing, if you're looking at the daily time series of all those variables, and you see the coincidence of an extreme rain event, and then the next day is warm, you kind of know what happened. It's just this big surge of the tropics to the mid part of the country, and then it didn't last long because it's April. But if it's in July, it can last the whole month if that happens. So that's a good point, Mike. So yeah, pretty interesting what's been going on this month. I was surprised it was only 3.3 degrees, but upon thinking about what you said, Greg, you're right. We never really had a bitterly cold day. We just never had a warm day.
Yeah, no, if you just move your finger from January along the middle of the climatology, you can see it's just all high variance, and then it gets into this area where it's almost the same every day.
Yeah,
with
yeah.
a couple excursions.
Yeah.
I think it's just monotonous.
Yeah, that's right. And I would say that anecdotally, again, looking at this time series with all of the very short period fluctuations, that's unusual. We've had short period fluctuations, as you point out, all the way until about the middle of March. And then those are the first and only times this year where we've had fairly consistent 5 to 7 day periods where things didn't change too much. But before that January and February is really unusual looking to me. It almost looks thin. It almost looks like this data that's missing compared to what you usually see.
This is one of these random statistics that may have no meaning, but I'm wondering if you were to look at the time series, and we have it, I guess, in front of us, are there particular times of the year when the variability is much shorter, like big ups and downs?
Oh, yeah.
Versus sort of a slower time
I
period?
think there must be. I mean, you could do
And I
a
think it's this
power
time of
analysis
year.
on this, couldn't you? Because this is you could do the highs and the lows, and you could do a power spectrum on that and find that out. And I suppose there might well be times of the year where there's
I think
longer
this is
period duration.
reversed. I think it should look
Yeah.
like it does now in the winter.
That's right, exactly right.
Right.
I think the same thing. If you look at, let's just for the fun of it, Pete, let's look at 2019 for these first few months. So this is the UPC for this year. Well, it was kind of the same, but here you go. Here's Michael, there's less day-to-day variability at that time of the year, but this, I don't know if this is characteristic. It would be really interesting to know that. I think it wouldn't be that hard to do it either. You just need somebody who's interested in it. Because that could be pretty fun. Find the power spectrum for the high and low.
But April, I think, just has a wider thick line.
Yeah, so here's April, approximately. Yeah. So, okay, very interesting stuff. There's always something interesting to talk about here. So let's take a look at we looked at the satellite, so let's look at the radar now. Sorry. Okay. So here's the radar over the continental U.S. There's the little bit of snow that's falling over northeastern Maine. That's probably not very unusual for them. It probably happens every other year, maybe every third year or something, for them to get a decent amount of snow or snow in the air late April. But here's the convective activity over central Missouri, kind of roaring through the Kansas City area this morning or south of it, and then into the central part of the state like Columbia. And the front edge is making its way towards us. The dew point here was only 34 this morning with a temperature of 46 or 47. So, and that's at the surface. So I'm guessing the column is relatively dry, and that might account for some of the erosion of this echo as it makes its way to the north and east. But that's yet to be seen what we ought to expect out of this as the day wears on. And this does look like a separate convective line, convective blob maybe, over the Dakotas and northern Nebraska, although they're both connected, as we'll see in a minute, to an evolving cyclone that is getting itself organized like on the Colorado-Wyoming border. And we'll see that, I think, more obviously at upper level charts than we do on the radar, because some of the precipitation elements close into the cyclone center are not so well put together. And I think you couldn't even see it, your attention wasn't drawn to it even on the satellite, because the cloud shield isn't so well put together yet. But I think that's going to change as time goes on. We'll see in the forecast if that, in fact, turns out to be true. So let's take a look, Pete, if we could, at the surface map first. Okay, so the places of interest were in central Missouri and Iowa, so we have light rain at the few recording stations that are reporting on this map. There's a thunderstorm just to the east of Columbia, and to the west of Columbia, east of Kansas City. So there's one thundering element in the set of observations, but there's probably more than that actually occurring. And it doesn't seem like there's any thunderstorm reports in Iowa either. And the dew points aren't extraordinary, although they're in the mid-50s, and temperatures are only in the mid-50s, so the relative humidity is quite high in many of these locations. Dew points just south of where it's precipitating are higher, in fact, across the whole state of Oklahoma, except for the Panhandle, dew points are over 60 in almost every one of those stations. Maybe we can slide up and see what it looks like down in Texas, where, yeah, dew points are uniformly in the high 60s in most of the locations. To the west, of course, that's not true. Look at this contrast. 83 over 65, 83 over 18 at Lubbock. So that's a pretty remarkable dew point contrast, and a 90-degree wind shift. And there's a pretty decent wind shift all the way across this dry line feature, it looks like. So that's a pretty nice feature. It probably has a lee side connection as well. So that's a pretty decent feature across western Texas. And I think you can even argue that you see it all the way up into central Colorado, where almost Colorado. I guess the dew points on the plains are a little lower, but here in western Kansas, it's 53 dew point, and the dew point is 6 here to the southeast of Denver. I mean, that's pretty dramatic. So the whole thing is kind of interestingly put together. The winds around this evolving disturbance seem to point for a center of circulation about right here. We're almost on the Kansas-Colorado border, with pressures around. They're adjusted too, which makes it a little more difficult to believe, but somewhere in the 997 to 995 range. So that's about where one might expect development and organization of all the stuff that's going on in the Central Plains. Okay, let's see, go up to Maine, Pete, and see what's happening in the northeast part of that state for the fun of it. So, snow observation. Oh, there's some snow in Caribou, 36 over 32, so moderate snow, probably big snowflakes. 41 over 37 with a northwesterly wind off the Bay of Fundy at Halifax. That's the worst place in the country, in the whole North America to be right now, in my opinion. I don't want to be there. That's awful. I think that's probably enough for this. I want to look at the upper level shots, unless somebody wants to go someplace else.
Satellite? Did we see satellite?
We didn't do the West Coast satellite yet. Let's do that. We should do that first. Yeah, because there's this really nice little disturbance out here, just off the coast of Washington, Oregon, and British Columbia. That's a really pretty little disturbance. On Wednesday, in class, it looked like there were 3 very small scale features lined up well off the coast. Seems to me that one of them emerged from that collection of 3. I didn't pay enough attention to make a reasonable guess about which one I expected might survive, but this one really has taken on a pretty decent shape, sort of a classic extratropical cyclone shape. Relatively small scale, though, as they go. And then this one farther to the west is rather dilapidated. The center of circulation is here north of the Aleutians in the Bering Sea, and there's the cloud mass that used to probably make up the cold front and some of the warm frontal cloudiness here in southwestern Alaska. But it's not well put together anymore. This one is. I wish there was a way to tell how much it's precipitating. There probably is. Angela's going to tell me what I can do to find that out, probably. I don't know what it is off the top of my head, but I bet it's a pretty decent cloud and precipitation shield associated with that. Just maybe moving into the far western, northwestern edges of Vancouver Island right now. Again, second Friday in a row, Greg, really dead ITCZ in the Eastern Pacific. So that's kind of interesting. So, we were talking about this today, Ben's research with Angela, the nature of the difference between isolated and organized convection in the Atlantic basin, but here there's nothing that stays organized anyway, and then maybe it never was.
It looked like there was something going on south of New Orleans on that radar.
Yeah.
Oh, let's take a look back at that. One last thing here, though, before we do. Here's the state of Hawaii, and there's something growing well to the west and somewhat to the south of Hawaii. So this is on the northern border of the tropics at the date line. So that's an interesting type of feature. It almost looks like there's a sort of a baroclinic leaf structure trying to develop, and then there's this cluster of convective activity back here. And if I had to guess, maybe this is a cold upper trough right along the northern edge of the subtropical jet, which is interesting. I don't know how it got there, if I'm right. I don't know any of the answers to any of those questions. But that could bring some rain to the windward side of the Hawaiian Islands, or the lee side of the Hawaiian Islands, Kona Disturbance. Yeah, let's go see that again, Greg, in the Gulf of Mexico. Pete, thanks. So this right here. Sometimes, for me, it's difficult to tell if this is not, in this case, I was going to say sometimes it's difficult to tell if it's active convection or not, but this clearly bubbling over at the top, new cold cloud mass. clearly at the top of updraft. So, yeah, I wonder what that is.
It's in the middle of an anticyclone. I'm guessing it's some kind of tropical characteristic to it.
Yeah, okay, so let's, when we get to the upper level chops, we remind ourselves we're just off between New Orleans and Pensacola, and see if we can't see where it sits. with
Subtropical
respect to
jet
those.
is north of there,
Yeah.
so what there is of it.
Yeah,
Can we
that's-
see lightning? See how that?
Oh, yeah, let's see if there's any lightning. Yeah,
A little
there's,
bit.
yep, it's pretty active lightning. I like that. Okay, so we got a few things to try and put into their large context here in the next survey of the upper level chop. So let's start at 500 millibars beat.
I guess you probably want just a single.
Yeah. So here's this morning at 12Z, and our interesting convective feature is really not obviously connected to any structure at upper levels at 500 millibars. I mean, we had a cyclone though developing. We were kind of placing it maybe in the eastern plains of Colorado at the current time, and maybe broadly in this whole portion of the state, and that's immediately downstream of this upper trough, which is got a curious characteristic, not an unprecedented one. Strong winds on the western side compared to the lighter winds on the eastern side of the trough axis. So tending perhaps to dig this upper trough feature. That is one of the ways that I've always kind of thought about that. The shear vorticity here is larger, and that tends to help the heights fall on the backside of the cyclone as opposed to allowing it to progress. And so I think that might be what underlies this period of time where the storm is trying to take shape. It's also trying to take shape at upper levels in an interesting way. The temperature contrast up there is pretty good. I mean, we're talking about minus 23 at Billings. I don't know, I can't quite read that one at Lander, Wyoming. It's minus 28 perhaps, or maybe minus 25. And then we're as warm as minus 14 on the southern side of that baroclinic zone. So if I had a pencil, I'm going to draw this a little bit more sharply. I'm going to also clean up the geopotential height lines. And I'd have a pretty good sense. I like this kind of upper frontal structure. It might not be the strongest one I've ever seen, but it's a pretty decent one for late April. And it's in the right position to amplify this trough and continue development for a prolonged period of time over the western panhandle, say of Nebraska. And then downstream, the ridge is pretty intense, and I think we didn't see the surface sea level pressure analyses, but I think there's a big ridge of high pressure over the mid-Atlantic states, so they have a pretty nice spring day there today. But here's a deep cutoff under which our rather not so well put together maritime cyclone is sitting, and there's a little bit of snow in Caribou that we just saw as well. So this thing is fully occluded, equilibrated, as the dynamicists say. And then here's the upper trough off the coast associated with the cyclone that we saw nicely presented in the satellite picture off the northwest coast of the United States.
You know, I think, I get the impression looking at that there's a southern wave train going through Mexico and maybe coming out in the Gulf. You see how that...
Well, the geopotential height line dips down for sure.
Yeah, I see the height line, and it's kind of opposite what's going on to the north.
Yeah, which is ridgy here. But the winds, it's unfortunate, the winds don't really tell that story
No.
precisely. It'd be nice to have one right here. You'd like to know what the wind is there. But maybe we'll see something at a higher level. So let's try 300 millibars speed. I agree with you, Greg. That is conspicuous, but somewhat unsupported. And yet here at 300 millibars, maybe it's a little bit better supported. You get a little bit of a southwesterly there on the tip of the Yucatan. And these are all kind of got a northern component to the westerly wind. So there is a broad trough here, one would have to say, looking at that feature. But boy, to really nail it as the feature that's driving some of this convective activity here would be a hard sell.
What are those wind speeds down there at Brownsville? Can't read that.
That's 45.
45?
Yeah, and 50 just to the west.
There's a warm sea surface temperature anomaly that goes right in between Louisiana and Florida, north from the Yucatan Peninsula.
Like here?
More, slightly more angled like this. over 27.5 degrees Celsius. So that is coincident with where we're seeing that convection
Okay.
here, so it's.
Do you have an idea how anomalous that is from what you're looking at?
Yeah, in a very broad sense, it is anomalous warm, in that area.
So while we're at 300 millibars, I'll just draw your attention to the fact that the jet structure on this upper trough is on the western side. Almost always, that digs the trough. It's also true to maybe a less dramatic extent to this feature that we saw right off the west coast of the U.S. with the cyclone and the satellite to the east. So that could be a slightly more developing upper wave than it might have presented itself to be. This one certainly has an intriguing structure, which I think portends further development in the immediate lee of the Rockies. That could be a really interesting development. Let's go to 200 and see if we see anything more associated with this stuff down over the Gulf of Mexico. I think it's more obviously trough-like for sure. I mean, this confirms that there really is a wave, a broad-scale wave in the subtropical jet at that latitude. But that's about all I'd say that it tells me at this stage. But that might be enough, I don't know.
There's not much in the temperature structure either from 500 all the way up to this level. There's
Yeah,
not
no,
much.
that's right.
So it's probably just a subtropical jet, and they're usually confined to the UTLS. They don't, their thermal structure doesn't extend much lower.
Yeah, true, that's right. And this is a weak exit region of the subtropical jet stream, and that's kind of in the right spot.
Yeah.
And here's the dying jet aloft. The higher you go out of this polar jet, you get to weaker and weaker wind speeds with that feature, but it does extend that high. The same is true with the one on the western side of that upper trough. So,
But there could be a relationship between the subtropical and the polar jet. I don't know if a merger, but there may be some cooperation as this trough moves
you mean in the future?
in the future.
Yeah, these
In
two
the
features
future.
here, they're not so far away that it's impossible that something interesting happens over central Texas, let's say. Let's go to lower levels now, Pete. Let's see at 850. I like to see what's happening. People have been asking me, on this, my friends, where is this cold air coming from? And there's really not a giant reservoir left by the end of April for cold air at high latitude. You go up to the archipelago and you're in the mid-minus teens at 850. That's not that cold. You don't want it here, but it's not that cold. So there's really not much left. The sun's been up for 5 weeks. It's just maybe much longer than that up here. So it just makes it hotter and hotter to have sustained pulses of cold air. And this is reflecting the climatology. It's not really that surprising, but we're only 3 degrees below normal. I'd say no matter what happens next, it's safe to say we're not going to be 5 degrees below normal and in the 50s throughout May. I don't think that's going to happen. We might have a May day like that, but I don't think that's going to happen generally. So here's evidence at 850 of a broad-scale circulation that I think has a couple of different hotspots. One of them seems to be in western Kansas, the other one in eastern Wyoming. Both of them are immediately in the lee of the high terrain. And I have a feeling that that's going to play a role, but not the only role, in developing this thing. My guess is that this broad disturbance will take on a somewhat unusual shape. It'll have an inverted trough structure to the north of the central cyclone sea level pressure minimum when it does move off the Rockies and into the plains. And there'll be a period of development that will coincide with that evacuation of the Rocky Mountain area. And I think that we'll have a pretty decent amount of precipitation associated with this. We see that the dew point depressions here, or the dew points are quite high. This is only a 4-degree dew point depression at near Dallas. So even at 850, the dew point's 12. So it's pretty incredibly moist air that's going to be involved in the circulation around this cyclone. In the development will involve vertical motions that bring that air upward. And really strong winds. We've got 30 and almost, there's no 50-knot wind, but there's 45 at Oklahoma City and there's 40 at Topeka. So pretty strong low-level jet in this vicinity as well.
Ridging goes way
organized.
up
Sorry?
into the Hudson Bay. That ridging, it's
Yeah, right
it's
here,
quite
yeah.
impressive there on the east side of it.
It is a very impressive ridge. And remember, that's where the 500 millibar ridge axis was right about here. And so it's just where it should be relative to the upper level flow. And then the storm off the Pacific coast that had such a nice presentation in the satellite movie has clearly got an occluded thermal structure as according to this analysis. It'd be nice to really be able to be certain of that, but it does look right with the trough, the thermal ridge axis goes right through the trough axis here. And then there's a warm frontal structure and a cold frontal structure. So it's a pretty good looking mid-latitude cyclone. An occluded mid-latitude cyclone.
I think this ridging was not planned in the progs. That I remember earlier in the week on all these long-term forecasts they were putting out, they weren't expecting the temperature to get much out of the 50s.
Yeah. For today.
And now we're well into the 60s.
Yeah, today's unusually warm. I agree with that. I don't think I expected it was going to be mid-60s today, and it's kind of a nice
It must be because the
surprise.
strength of that ridge is more than was
Yeah,
forecast.
because it's not really that this thing has gotten itself put together, and like last Friday and Saturday when we had that really strong warm advection because of an intense cyclone, it's the combination of two moderate features, and we're in the channel of strong southerly advection. Yeah, that's probably right. That's probably right. So that's what I have for today. So thanks, Pete, for driving around.
Thanks, John. So we're gonna do something a little bit different, go halfway around the world, or so, and I guess, let's see, where do we wanna start? Let's start with the two images here. Let's do the Twitter one first. So, as you may have heard, India is experiencing a significant heat wave, and here's from the top 10 cities. Uttar Pradesh is the most populated part of northern India. It's one of the states there that has about 200 million people, and they're experiencing temperatures 45 degrees Celsius. I had to do that. I normally can do temperatures, the conversions easily in my head. When you get up to about 34, 35, I lose it, but that's 113 degrees Fahrenheit. And they're having nighttime lows that are cooling off into the middle to upper 80s. What we'll see with this heat, and I'm not trying to diminish it at all, we're going to look at some surface maps. The dew points are actually relatively dry, so it's, I mean, I hate to say it to make light of it, but it's sort of a dry heat. But it's still, for large populations like this, experiencing heat of this sort, that certainly puts a strain on their power supplies and things of that sort. Another image back here, the next one, shows a time series from Delhi. This shows their temperature record, and in red, so here's their mean, here's the daily extremes. But you can see here, over the last 6 weeks, as this individual, Dr. Robert Rode, has said, the last 6 weeks, they've been sort of nearing the top of their historical record for temperature. So this
What's
has
the
been
green line?
extremely, green line, I think, is the mean
Climate?
temperature, yeah, climatology. I didn't construct this, I just.
Man, that's a long time, isn't it? That's like a 5-week period where they've been skirting with the all-time records.
Right.
Wow.
So this is extreme heat, and we're just going to look at it a little bit from a couple different perspectives.
Well, I should
Yeah.
point out that it is typical this time of the year for India to get dry heat, quite a
Right.
bit of it. That's leading up to the monsoon, and the monsoon is when that all breaks down.
Right. So this time period is one that's characteristic of significant warmth, but just the amplitude of the anomalies are
Yeah.
pretty extreme. So we will go to the terminal window. We have some GEMPEC fun to look at.
Oh, wait a minute, one thing,
Yeah.
go back, just to point out. Notice the annual curve, how it dips and then goes back
Yeah,
up
that's
again?
That's monsoon.
That's the monsoon.
Okay, so let's get down to the terminal. And just another statistic of interest, there was a station in Pakistan yesterday. This is, my apologies for the pronunciation, Nawabasha, Pakistan got up to 117.5 degrees Fahrenheit yesterday, setting a record. So this has been not just India, but Pakistan as well. So go to this first terminal, actually, right here. Please, Pete, if you click on this, and just do run. Okay, GEMPEC window should pop up. This is from earlier today. This is at 9Z. And I guess it's the first GEMPEC window down here. It's one of these three. Not that one yet. Next one. Okay, so this just shows some of the temperatures during the heat of the afternoon for them. Earlier today, this station right here, which is Ambedkar International Airport, got up to about 114 an hour after this time period. But you can see the extensive heat temperatures in the over 105 in parts of Pakistan. Here in India, that Uttar Pradesh, that state is roughly in this location over here with temperatures approaching 110 degrees Celsius. So a really warm period for much of this part of the globe, extremely warm. But you'll note, again, dew points in some of these areas, not exclusively all of them, in the 30s and 40s, maybe 50s, which isn't generally too tough to take. Then when you get into the southern part of India, you have dew points approaching 80 degrees Fahrenheit, so that's pretty brutal.
I think the monsoon normally starts toward the Bay of Bengal on the western side, and then the eastern side, it works its way up, usually from mid-May to mid-June. It works its way up the west coast. That looks like what you're kind of getting there. The southern part it's got some humidity, and then up to the northern Bay of Bengal, but the Arabian Sea is still very, very dry this time of year.
But this is a significantly populated region of the world experiencing this extreme heat, and just the suffering that's associated with it is not particularly pleasant. If you go to this station on the International Airport, look at a sounding from today. You'll look at a dry adiabatic sounding. Look at that. You can kind of guess by just taking that air force layer, bringing it down to the surface, and then here's a super adiabatic layer just above that. That's getting to the mid-40s in terms of temperature.
I think that's a constant theta E profile too, all the way to 500 millivolts. I don't know if that's right. I can't tell all the other lines.
Theta? No. This is QT. You say constant theta E?
No, constant theta E, yeah. Because when,
I can't quite.
Theta E are the red lines, right?
Yeah. Theta E are these red lines.
Well,
right
Theta
here.
is a little warmer. I bet this is not totally clear. I bet there's some small cumulus associated with the boundary layer is essentially 500 millivolts.
yeah.
Right.
Is the top of the boundary layer. And if you're outside and you want to look at the little puffy cumulus out there, one that looks like a duck, it's going to be really hot.
Probably not going to provide much shade. I did look at some satellite imagery. I couldn't tried to find a nice satellite image. And again, the resolution, it was just over.
Yeah, it'd be
Good
small.
check. Yeah, you couldn't really see the cloud structure, but it's generally severe clear for those regions.
So how do you break the cap that's on top of that, except with a wave, right? I mean, it's not gonna be by daytime heating, you're not gonna do that. You have to have some wave come
There's
out.
not enough
Make that
moisture.
look-
Even if you did break the cap, you're not going to create precipitation.
Yeah, it's gonna fall into a dry layer, yeah. that's
Yeah,
right.
It does be wind.
But it is possible in these, I mean, we've seen this in Colorado before, this kind of boundary layer. And, you'll just see the little cumulus up really, really high. It looks like a duck, but I need binoculars to see it, And it's way up there, but normally what it is, it forms a mixed layer, this deep mixed layer. This is what you get over the Rockies on the high plains. This is the mixed layer, but then that's at a higher elevation, so when it moves eastward, it's an elevated mixed layer.
Yeah,
But
yeah.
here it's right at the ground.
Right, and this is in the central part of India. Now I have a question. Obviously, this is as close to adiabatic as you can imagine. Why does the dew point profile, which is going to give you the mixing ratio, why is that not as well mixed? I mean, the winds are, I guess, light, right? So that's one part of it. But why is that the mixing that's occurring that's helping to create this mixed layer not mixing the water vapor as well? These are the green lines are the mixing ratio. Any thoughts on that?
Well, it's anchored to the surface to some extent from evapotranspiration, but so is the heating. I don't know. I mean, I think it just has to do with the surface boundary condition and the upper boundary condition, mixing between them.
This worked pretty well, right?
The heat is transferring the heat, the thermals are transferring heat from the surface and mixing it up there.
Right.
And that's to some extent true with the moisture, but it doesn't have to follow the same effect because the boundary layer keeps somewhat moist, it keeps moistening itself.
Right, so this is a bit more moist than upper levels, so there might be, some other effect that's going on. Anyway, that's just a curiosity for this. In terms of the weekend coming up, we have another tab here. Although you may have to first go to this one, please, Chief. And then let's take one of the terminals.
Yeah, Michael, that
Yes.
sounding you said, what's kind of the area that this is in? Is it like a rural?
This is in the central part of India, right dead center. Let me go back to the map, the surface map.
So is this inner city or agricultural or
It's-
what's the?
That's an excellent question, and I mean, it was taken right about here, but let's go to the surface map, please, Pete. station right here, and I can't tell you, it's near an international airport, which probably means it's a fairly populous city. But okay, so I was gonna go to, not this one, sorry folks, these all up that I had. Nope, not that. Just click on that. Just type exit GD plot. I know those of you that do Python, just, it's easier to plot with Python. GD plot, please.
Yeah, the maps are really good too.
All right, that's gonna take a moment to come up. It's a nice map. While we're waiting for that, this is gonna clear in a sec.
Is it this one?
Yeah, this is loading out. These are every 6 hours from the GFS.
Oh, wow.
Yeah, we have this data available. The temperature legend here is fixed with the temperatures. I just went from 72, and then everything below is going to be just a uniform color. But you can see the effect of the Maas sort of blocking the cold air well to the north. But you can see these temperatures just getting to extreme values in parts of Pakistan, over 117 Fahrenheit in these regions. And we can do a semicolon R just to loop it. All right. Look at these are every 6 hours. Have we move that off so you can see the temperatures? So we got things cool down into these nice yellows and greens, but that's only middle to upper 80s at night. So we got a pretty uncomfortable time ahead for parts of India and Pakistan.
Yeah, that's all. Ceylon's where I'd be if I had a choice.
Although it's probably very, very humid.
Yeah, that's true.
Imagine that. Anyway, just a different look at a different part of the world. Again, the impacts here obviously is, for human beings and human health, but also agriculture and energy. And we know that India gets a lot of its fossil fuels from Russia, so there's a whole international element of this as well, which is, I think, kind of an interesting thing. And to the extent that this has any relationship to climate change, and I'm not making that statement, burning more fossil fuels is certainly, in the longer range, not going to be the way you want to go.
This may be related to the stuff that's been going on in Iran with
In where?
in Iran. Haven't they, or is it Iraq? They've been having some big dust storms.
I haven't looked at that. I haven't looked yet, but I think
Shutting things down.
that would be something interesting to look at the relationship between what's happening here and other parts of the world.
That whole, the whole high or ridge, it's probably extremely strong.
Yeah, there wasn't, I looked at 500 millibar heights and there was no obviously strong blocking type high that was on there, so that's something that I would have introduced. But again, this is not part of the world I look at typically, but I thought this was kind of an interesting thing to share. Okay, thanks, Pete. We can click on that to stop it. GPN. It's like closing your Python notebook. But anyway, we will go back to our tabs. I had a solo window, okay. And we'll start off, or continue with looking very quickly at our Meteorograms. Finally get warm this week, or this weekend, 61 coming up for today. Tomorrow probably also, this is going to be the warmest day, but then a significant rain event as that weather system that's beginning to develop to our southwest begins to approach us. That's going to last through much of Sunday, but I think Sunday afternoon will be pretty decent, but cooler, a little bit cooler. Tomorrow, we're not going to get as warm just because even though we have strong warm convection, we're going to have lots of clouds and precipitation that'll keep us cool. All right, let's go to the meteorogram. On that, we'll see the significant ascent over us, starting at 0Z. So the AMS selected a really great day for doing something on the roof. Is it still going to be dry through early afternoon or through early evening? Then we see the significant ascent as the weather system to our southwest approaches, and that's when we see the precipitation beginning to ramp up. And from the look of this, it looks like there'd be sort of two pulses of precipitation, one coming in closer to around midnight, and then a second one during tomorrow afternoon before this thing finally ends. You can see this column becoming quite saturated, right? The relative humidity is going up. And even in the face of this strong warm advection, we don't see much change in the temperature profile. during this time. With the significant ascent occurring, we do get some cooling here, and then looks like even with the ascent continuing, or we can a little bit warm advection that kind of blends out at this point, I guess, we'll warm up a little bit before everything wraps up.
Yes.
And the dynamic tropopause, we'll see a little bit of a PD associated with the trough moving through on Sunday morning. Let's go back and look at the forecast maps as a loop. We're going to step through them first of all. Start for 12 hours of the forecast of this evening. There's a cyclone moving into the plains, central plains. 994 is the forecasted civil pressure. An area of convection on the Gulf, at least this was represented by this model. This is 6 hour.
You guys are competing with the speaker up front, so you can't do that.
Yeah.
Okay?
Is off in the Gulf of Mexico, but here is the significant precipitation just to the north of the cyclone in the region of strong warm advection. If we go ahead another 6 hours, move it slowly, 18 hours, so this is just around 1 o'clock in the morning. We see the rain is just beginning to get into the western, just to our west. The cyclone hasn't really amplified much. It's 997. It moved from Kansas northward into South Dakota. I presume the western edge of this is snowfall, but this is probably largely rain with a really strong warm advection out ahead of it. The weather system that John noticed in the North Pacific is now sort of made landfall in the western parts of the United States with some rain along the coast, which certainly is going to be useful for them. All right, let's go ahead to 18Z tomorrow. Let's go into the afternoon. The cyclone's kind of just trickling by, still 997. There's the significant rain over us. Cold front really shows up nicely in this particular forecast, and the precipitation along it. Broad areas where stratiform precipitation. With that warm advection, we'll see at 850 millibars. With the amplification of that thermal ridge, there's going to be a significant trowel-like structure that's forming. And if you look at the Q vectors, we'll see a nice Q vector convergence into that. And that's going to be associated with broad area precipitation as the upper trough interacts with the low baroclinic zone.
It's not exactly the Norwegian cyclone model. You got that precipitation band in Ontario and into North Dakota that has nothing to do with the traditional frontal boundary. But it's frontogenetically active region nonetheless.
Right. It's a really odd structure out ahead of here. It's ahead of this trough, at least in the thickness field. But that looks really odd. Okay, let's continue into another 12 hours beyond that. So this is 42 hours to our evening. With the arrival of the front, or the passage of that front, the heaviest precipitation is going to be over. We're now under this broad cyclonic circulation. And some of this might actually be snow to well to the northwest, but it's going to be a wet snow. And the cyclone, again, hasn't deepened significantly. It's now actually filled a few millibars, 3 millibars over the last 12 hours, and just slowly moving eastward. So I think the big thing that's going to be a factor for us over the weekend is going to be, after the rainfall's over, we have this broad cyclonic circulation to the extent that the boundary layer is still relatively moist. Getting Ekman pumping of the boundary layer is going to give you some broad ascent, and if it's moist enough, we'll get clouds, low clouds forming. Not much in the way of precipitation as this begins to drift out. We can go ahead another 12 hours. Let's go 6 hours to 48 hours for Sunday morning. There's still fairly active cyclone, but under this broad circulation, that's going to give rise to this lot of clouds that are going to be lingering over us as we go into Sunday. Sunday may be dry and breezy, but with occasional sprinkles. And if we get any clearing, it's cold aloft. As the cold air is beginning to arrive, that could lead to some more convective type showers. So weekend's not going to be a total washout on Sunday, but it's, Saturday will be wetter than Sunday, but Sunday's not going to be perfect by any stretch. The cyclone is slowly meandering across our area. So we go to Sunday evening.
It's probably going to struggle to dry up on Sunday morning, even if it isn't raining.
Right. So with this is the last 6 hours of precipitation, light precipitation over us. Maybe a little trough-like feature pushing through on Sunday afternoon or early evening. That might give some showers. But again, this is just really, the cyclone develops rapidly, moves into the central plains, moves northward into the South Dakota, and then kind of just drifts into the northern part of our state by Sunday evening, at least according to this forecast. Cold advections in, temperatures going to be cooler Sunday evening into Monday, but not super cold, which is, I guess, a great thing. let's go to 850 millibars and just take a snapshot at a couple times. We'll go to 24 hours, the rain's coming in. And a couple things to note, as John was saying, that area of precipitation to the northwest that goes into western Ontario from North Dakota, you can see nice confluence along this baroclinic zone, and that's good. You would expect then to see a band, perhaps precipitation if there's sufficient moisture, which we know there is. South of here, we're trying to amplify this, the warm sector here, so that's going to certainly help to create a region where we're going to expect to see some ascent as well. And then as the air begins to turn just to the south of the cyclone, it's more northwesterly, beginning to see some frontogenesis along this area with the baroclinic zone as well as the confluence, which could spark the precipitation we saw along the cold front. All right, let's go, at this time, let's just take a quick look at 700 hectopascal, the Q vectors at the same time. And as John had pointed out, very nicely, there's strong evidence of frontogenesis here as these Q vectors are directed from cold to warm. We kind of already saw that from the confluence and the temperature structure there. We see this convergence of Q vectors here along the isotherms. This is not perfectly, this is some frontogenesis here as well, but broadly an area of Q vector convergence in this region, which is going to be also a nice diagnostic for us. And then over parts of western Kansas and the eastern Colorado, we see that Q vector divergence, which is going to be clearing those areas out.
I think it's interesting. I think the Q vector convergence is probably suggestive of stratiform rain.
Right.
And it's hard to predict how that's going to go. On the other hand, the SPC is putting out a slight risk coming into southern Wisconsin for tomorrow and day 2.
So let's take a look at the SPC Outlook, and I certainly welcome those that are in 453, or Angela, if you have any great comments about that. Wow, look at that. Never seen that.
Yeah, I think what strikes me would be where you're gonna get the most unbroken cloud areas down like more towards northern Illinois.
Sorry, this is the day 2 effective outlook.
Yep.
So we're just on the edge of
So
that.
you'll look, the more severe probabilities are kind of just in northern Illinois for tomorrow.
That's you want tomorrow?
Yeah.
It's probably the warm front is between us and that, I would guess, but depending on how they're missing out on this surge a little bit, I wouldn't be surprised if it surges a little further north than what the blogs are guessing. We'll see.
Well, we could take a look. Let's look at although I don't think it's going to be much different, let's look at the GFS and pivotal and look at the surface maps. We can go into the upper, we can zoom into the upper Midwest for the regions. Also look at soundings. Click on that one, please, Pete. And let's go to, first of all, temperatures and winds. And we'll go to let's go to 30 hours, so 18 tomorrow. Thankfully, strong warm advection, I guess the warm front, to the extent that you can even analyze one on this. I think this is probably rain cooled air here anyway, right? Because you can see that strong warm advection broadly in this area. The only reason it's going to stay cool here is probably because of precipitation, I would imagine. But I don't see really a strong warm front here. I mean, there's a strong temperature gradient, but there's no wind shift along it yet.
No, there is a switch from stratiform to convective. I see that in the NMS model, and I see,
Okay.
but it seems to be the convective is going to stay south of us.
Scroll down a little bit.
But it just depends. I'm just guessing
Yeah.
they might be missing this.
So there's the band of precipitation that maybe cooled things off, but yeah, according to this forecast, we get that burst of, that was the initial burst of rain that we saw even in the MM5, that's already cleared our area. So like, I don't know if this is stratiform or convective, more showery certainly down here. With this, we're certainly in the warm sector of this thermal ridge by this time period.
Another thing, a point of contention with these prods is they seem to be struggling to figure out what's going on with that Gulf MCS that's down there right now. And
Okay. Let's go back to the poll.
I noticed in your forecast, you put a bullseye of precipitation down over southern Florida. We have another, in my NMS forecast, there's another bullseye of precipitation, not exactly where yours is. And you can see they got something down there. I don't think they have a handle on what this thing is in the Gulf right now.
Well, let's go back to sort of current time, 6 hours in the forecast. Maybe just step through, I mean, this is just, I mean, there are very few in situ observations here. You can get satellite winds certainly to help resolve this, but we, from John's analysis and our discussion, the Gulf is, there's no discernible feature in the Gulf, I guess, this morning.
Right, but it did look from the radar and the satellite, like this is an MCS, which is going to alter the pattern. It's
Right.
going to change what the initial conditions are of this. I think they're struggling to resolve what that thing is doing. And well, my guess is this is gonna change a lot in the next 24 hours. It's gonna change what the structure is down there, so that by this weekend, we don't know what's gonna go on with that.
But do you think this is going to have an interaction with what's happening?
Very well could, I don't know. I don't, we haven't been able to resolve it. We just see that it's pretty spectacular around the satellite.
Right, so let's go to the short-term high rapid refresh, because these are run every hour. Let's see if you have anything there.
Is there, are there any plots for sea surface temperature within any
SST,
pivotal?
I don't know if Pivotal has it, but I know, Sims has some SST things.
I'm just curious for how all the different models are initiating, because it
Second.
is like a 1 to 2 degree anomaly in the SSTs in the Gulf. If that's not put into any of the models
Oh,
when they're
look at
getting
that.
initialized, how is that influencing?
Is
the
that a loop
stability?
current?
Yeah, but I guess, the models do have the current SSTs in there. They don't have, most models don't, at least the operation models, to my knowledge, don't have a feedback between the atmosphere and the ocean. They'll start off with whatever the initial temperature structure is from the analysis, and then go forward with that. But I don't,
What Pete's just showing there with that warm anomaly in the Gulf,
Right.
even though it's on a big scale, it looks like the signature of a loop, of a loop current. And if that loop current is up in the Gulf, that might be, it certainly looks like that disturbance is sitting near the loop current.
right.
Although it might be more to the west, I don't know. But, well, that may say something about the future of this spring. More
Right.
than it does even about this weekend, but.
Right. But I think, throughout the Atlantic, this is just a broader comment, I think the SSTs have been warming on the order of a degree or two over the last month or the last couple of weeks. It's been warming rapidly over parts of the Atlantic.
Right, but the loop current is different.
Right.
In that it represents deep, warm water in the Gulf, which is conducive to tropical development and strong tropical development. And you don't always have a loop current, and you get anomalies, but this doesn't look like the way that looks on there, I'm guessing that's not an anomaly. We ought to look up loop current for next week and see how that's shaping up, because that really is a way to forecast the intensity of storms during the summer. We saw something like that happening in 2005, for instance, with that kind of loop current earlier in the year, and then by the time you get to midsummer, that blossoms into something big.
So since I was going to look at a suite of different model runs, we looked at the curve just briefly. There wasn't much that was obvious there. Let's just bring up another tab, please, Pete, and let's go to the Hurricane Center and see, are they even, does that say anything of interest about it? If you go to their weather discussion, tropical weather discussion. Here, special features.
Gulf of
Some
Mexico.
things that are more in the Caribbean, but for Gulf of Mexico, not much at this
Not
point.
very much of it.
But it's certainly something that looked more organized than we've seen in some of the models at this point. So, something to watch for. The last thing I want to just point out, which is a bit of a disappointment, we go back to Pivotal. You gotta look at it.
Sure
GFS. You know that you know, this is something that's probably not gonna happen if I have to look deeply for it. Let's go back to the 12Z forecast from yesterday. And let's go to 159 hours. Maybe it's a little further. Let's go to 183 hours. Hey, let's go 174, we'll find it. I saw this yesterday, I was like, wow, this was in the forecast, this produced 7.9 inches of snow for us. Not all at once, but if we were to then just go back and see how the forecast has devolved over time from this. The 3 runs before led up to something that looked really nice. And I haven't done any of the homework of going back to see what was the trigger for this particular disturbance. But it's not going to be particularly cold, or it's going to be chilly. And actually, how's the thickness changed over us if we go back to yesterday, 12Z?
That's 558, is it, or 552?
This is 552, is just south of us. Yeah, it's
Pretty different beast.
This is a different beast entirely. So if you're looking for snow, don't look here, or look at past forecasts and sort of.
What did ECMWF do with this? Was it buying into anything?
No, ECWF was more sensible. But again, it hasn't happened yet, or hasn't not happened yet, so.
It hasn't not happened yet.
A couple double negatives there.
Yeah.
But this is yesterday. This looks more like the current forecast now with something well more south and much higher thicknesses. So, we'll see, we'll see. And the fact that the models took it away, the models may bring it back, but that was the disappointment of this
Yeah.
week. But the week ahead looks rainy again, looks wet, and not super warm, but
Not as bad as-
snow chances are gone
Yeah.
at this point. Anyway, well, that's it for today. Thank you, John, thank you, Pete, thanks for the questions, discussion.
Thank
What's
you,
the
Michael.
forecast
Thanks,
for,
Pete.
what's the forecast for the rooftop party? Dry and 61.
Pretty nice.
Windy. I'd say not super windy, I don't think. But we could, well, let's bring up moss, and then we'll finish it.
Moss?
Right. Weather minus C, 8 new avian moss. Okay, that'll do it. Please, the probability of precipitation around by 0 Z, which is 7 p.m. I guess we'll be wrapping up by then. 19% over that 6-hour
Yeah,
period, but
about
temperatures just, around 60 or so and dry. And then for the weekend, you can see, first of all, the most likely precip type was rain. We weren't thinking about snow at all. 57 for tomorrow, and then a little bit cooler on Sunday. And the probabilities of precipitation aren't particularly high on Sunday, but you probably want to have a rain jacket or something handy if you're outside. And winds, that was the other thing. On the roof, actually, it's not, that's breezy, 14 knots or so out of the southeast. It's pretty cool up there with the clouds. Anyway, that's it. Thank you very much.
Thank you, Michael. Thank you.
I think, Michael, it'd be interesting to do one of those soundings like